Hey everyone, welcome to Math 133 Day 22. We are going to talk about the cumulative review number 6. That is in your course pack on page 591, page 591. Um, so next week on Tuesday and Thursday, we'll be talking about chapter 10 stuff. So Uh, Chapter 10 is about hypothesis testing, and that's going to be our topic for the rest of the semester. But today we're going to pause before we jump into that and do the cumulative review and review all the stuff that we've learned up to this point. Okay. Um, there's a couple of different cumulative review worksheets in your course pack. We're skipping cumulative review number 5. Um, we might have skipped cumulative review number 4. Did we? Let me see here. What was our last cumulative review? We did cumulative review number 3. That was a while ago. And that covered like chapters 1 through 5. So yeah, so we skipped cumulative review number 4 and number 5. So those might be good to practice on your own, okay? Because just like on the final exam, uh, everything's all mixed together, right? So, like when we're doing the chapter 9 review, you're like, okay, this is all about chapter 9, okay? And it's all on the same page in the exam notes packet, right? It's on page 259, right, for chapter 9 stuff. And that makes it easy. But like on test day, on the final exam, your exam notes packet, your exam notes packet is huge, actually. It's like 14 pages. And so I don't want you to have to be flipping around like, where is that? I don't remember. Like, where's the chapter 4 stuff in here? Right? Um, so practicing these cumulative reviews where there's questions from lots of different chapters is helpful for trying to remember, like, where was that formula and stuff. And honestly, I would recommend you have your 8.5 by 11 piece of paper, right? You're going to be able to bring two of those to the final exam. 8.5 by 11 piece of paper, front and back, whatever you want written. And one of the things you might consider writing is there's 14 pages in this exam notes packet. It might be a good idea to write down page 1 has this stuff. Page 2, if I'm looking for the three methods for calculating standard deviation, right? We had method 1, method 2, method 3. That's on page 2 of your exam notes packet, right? Um, so writing those down might be helpful so that when you're on the final exam and you're like, okay, I need to calculate the standard deviation of this. What page do I look on in the exam notes packet? Instead of having to flip through it, you can just look at your little table of contents. Anyway, it's up to you. So page 591 though for the cumulative review, and this covers chapters 1 through 9. Okay. Uh, we just finished chapter 9 on Tuesday, so um, let's see here. So I'm gonna ask you guys for some help get putting these hints on. Okay. So we're gonna go through or give some hints, but so question number 1, scatter plot here shows the relationship between the U.S. states average per person income and its food insecurity rate. Um, so all of this stuff here, like the strength of the relationship, regression equation, the steps for calculating it, all of this different stuff, it's in your exam notes packet. What page is it on? If this was test day, where would I go to find like the script for this, right? Rachel's got it. All the stuff is on page 255. Yes. That's all the chapter 4 linear regression stuff, right? So there's a number line there on page 255 for What's the relationship? There's a script for the interpreting the slope, right? If you write out what x is, increases by 1, write out what the unit of x is, then y is expected to increase or decrease by approximately, you write out the slope and you put the units, right? Okay. What's the y-intercept? Remember, y-intercept is a point on the line, so you need 0, comma something. And explain why this does not make sense. There's a script for that. There's two scripts for the y-intercept. One is when x is 0, y is expected to be this. Most of the time, though, you're going to use this one, which is impossible for something. Impossible for, and then you write out, and usually the problem is the 0. Usually it's x can't be 0, so you write out what x is and explain why that's a problem, right? Okay. All right. So, uh, good job on there. All right. Next page, page 592, number 2. The following probability distribution is based on research of a random group of US adults. The random variable x equals the number of days that they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. Okay. Explain why this is a valid probability model. So it's a valid probability model because uh, sum, that's supposed to be an S, of probabilities is 100%, right? This adds up to 100%. And all probabilities are between 0 and 1, right? That's if you wanted to write it out in a sentence, write it out in English, right? Um, if you wanted to write it out in math, capital sigma stands for sum. Probabilities is 1. And all the probabilities are between 0 and 1. Either of these is fine. I like this one, but that's because I like math and I can understand what all this means, right? You write this, in a text to someone, they're gonna be like, I don't know what the hell you're talking about. So, uh, but there it is written out in English as well. Um, they probably wouldn't understand this anyway if you don't text this to someone. All right. If a single random adult is selected, what's probably okay? Um, so the word or in statistics means you have to stop and think for a second because it's going to depend on whether it is disjoint or not disjoint. Okay. So disjoint, you'll remember, means cannot happen together. And not disjoint means can happen together. By together, I mean like it can't happen at the same time, or can't happen, and this can't happen, right? So, um, so all these probabilities, so the probability calculation for or and not and uh, all these different things. Um, Where would I find those in my exam notes packet? There are probability rules somewhere in there, right? The most complicated one, I think, is the one that says, what's the probability that at least one of these things happens, right? That one's like two problems in one. So what page do I find the probability rules? Rachel's got it. 254. Yes. So if you have disjoint events and you have an or, you just add them together. If they are not disjoint, then you add them together and you subtract where the two events both happen, the intersection, okay? Probability of at least one is kind of like two problems in one. You have to calculate the probability of not that event, and then you have to do one minus that to the power of n, right? It's crazy, okay? So we give you the hints so that, you can go and study this, like when, when you do all these problems, you can go back and say, okay, where was that? But also so that like you get used to using the exam notes packet, because on exam day, like I said, I don't want you to have to flip through. This thing is huge. I don't want to have to search through, try to find the formula you need. That's going to slow you down, right? Find the mean of the probability distribution, find the standard deviation of the probability distribution, interpret the mean and standard deviation. So where do I find how to calculate mean standard deviation? What page is that on? There were three methods for calculating mean and standard deviation. Do you remember what page them three methods are on? The next question is going to be which method is it? So, yep, it's the same page, 254. Probability rules are down here. The three methods are right above it. Okay. Um, what method are we using here? Method one is raw data in a single column. Method two is a frequency distribution. Method three is a discrete probability distribution. Which one are we doing this time? Yes. Rachel's on fire. Method three. Absolutely. Probability distribution, right? They told us it's a probability distribution. So there we go. So yeah. So maybe, it'd be a good idea. So we say like, okay, so exam notes packet, uh, you got page 253, right? So what's on page 253? Page 253 is like z-scores, bell curve, right? Z-score formula, normal curve, right? What else is there? There's percentile stuff, percentile script, right? Page 254, we just looked at, that was the three methods for mean and standard deviation. And then it was also probability, right? Page 255, that was all the linear regression stuff. I don't know. I would I I would find this helpful if I had, on test day, have that written out so that when you're like, okay, I need to do uh binomial probability, and I know there's something I have to do for StatCrunch for that, but I don't remember what it was. Where am I going to find that? Well, page 256, binomial probability, stat calculators, binomial. Okay. Or you don't even have to write binomial if you're just like, you want to write it out in your own explanation. So so that when you see, okay, I see this kind of problem, I know I need to go here. There's my StatCrunch steps. So there you go. There's the start of it. Right. There's four of the pages. There's 14 pages. It's a lot. So all right. Moving on to the next page. Page 593. A random sample of US colleges taken in state tuition is here. Assuming the central limit theorem conditions are met, compute the standard error of the sample mean. Standard error, that was the SEX formula, which SEX bar, sorry. Does anybody remember where to find that? There's some formula for that. Flipping through, looking for it. Which just says page 259. So on page 259, at the bottom, we have the confidence intervals. So this is the formula for confidence interval for a single population mean. So this is the formula for constructing a confidence interval. Here's the StatCrunch stuff. Um, so I see the standard error of the mean, standard error of the sample mean. It's right there. But where's my formula? Well, I don't really have a formula here. So uh, this is a formula that we talked about in class, but wasn't actually written in the exam notes packet. So you are allowed to write on our exam notes packet. I know that it says like don't write on this. That is for a different teacher. I will allow you to write on this. Um, so it's S over root N. Yes. So, uh, yeah, if you want to include that on your exam notes packet, and then over here, what is this? Page 259, you can include the standard error. Or, if you wanted to just have, if you just want to have the formula right here on your 8.5 by 11 piece of paper, it's not that big of a formula, right? So this is confidence intervals on page 259. All right. Pew Research Center survey of a bunch of internet users found that 1,000 agree that online dating is a good way to meet people. Describe the population for the poll. Population is all something. Okay. Based on these data, compute the point estimate for the proportion who agree. Um, so the point estimate is either p hat or x bar, depending on whether you're looking at populations or means, sorry, proportions or means. So if we're looking at proportions here, calculate your p hat for your sample. If you're looking at means, calculate your x bar. Um, Pew Research Center wants to replicate the study, but needs to figure out how many people they must survey. Using the point estimate as a prior estimate, calculate the minimum sample size required to construct a 99 conference. Okay, so margin of error. Okay, so for this, you need your formula. We're on page 593. Formula, substitution, and a result. Okay. So for this, what page is the formula that I need to calculate the minimum sample size? Page 261, yes. So on page 261 is the sample sizes, how many, and it actually down here, I also have what we're going to talk about in chapter 11, where we're going to talk about sample sizes and calculating how many. So we're putting together like a table of contents for our exam notes packet. So you can write how many, or sample size formula, right? All right. Next, we're on page 594. Find the critical values for an 88.5% confidence interval for P. Show correctly. Okay, so you guys can do that. I'm gonna skip that one. In 2014, there were roughly 500,000 electric vehicles on the road. You want to construct a confidence interval for the average miles per gallon equivalent these cars had in 2014. Table here shows miles per gallon for 5 random cars. Verify the conditions are met. So we need to verify random, normal. Well, the order you verify them in doesn't matter. We'll do independent, because that's what we're used to doing. But if you do normal first, it doesn't matter. Independent and normal. They don't have to be done in that order. Okay. Uh, Based on these data, construct a 90% confidence interval. We need the formula, substitution, and the result. So, okay, I need to make a confidence interval. So what are confidence interval page 259? All right. That's all the hints for today. Let's jump back and do some math.